Physical substance in the universe. If it has mass, it is matter. But then there's this other thing called antimatter. During the Big Bang, the universe should have created half and half. One atom of matter, one atom of antimatter. But look around you. Matter is pretty much everywhere. Where'd all the antimatter go? This is one of the great mysteries of physics, and the scientists are working on it right now. Antimatter is the same as matter, but opposite. Scientists have been looking for antimatter since it was theorized in the 1920s. Physicist Paul Dirac was trying to reconcile two new chapters in physics, Einstein's theory of relativity and quantum mechanics. Think of it this way. When solving for x squared equals 4, x can either be 2 or -2. Up to this point, physicists had spent most of their energy, physics joke, on the positive solution, but not on the negative one. But since both give you the same result, antimatter must exist. Obviously that's very simplified, but that's the idea. So if you picture hydrogen, one positively charged proton, one negatively charged electron, that is matter. Balanced and simple. Antihydrogen is made of a negatively charged antiproton and a positively charged positron. This evil antimatter twin version has the same mass, by the way. Experiments with antimatter in the journal Nature from November 2015 found that antimatter behaves exactly like matter, which is actually confusing. Shouldn't the opposite particle behave, oppositely? More research is needed. The base rule of old physics is matter cannot be created or destroyed, but sorry, old physics textbook, that is not strictly speaking true. And in fact, when an electron hits a positron, they will annihilate one another, turning into energy in the form of gamma rays. Specifically, gamma rays at 511 kiloelectron volts. To scale that up, if 1 kilo of antimatter hit a kilo of matter, based on E equals mc squared, the resulting explosion would be 3,000 times the Hiroshima bomb. So, new physics, energy cannot be created or destroyed, because matter and energy are the same. This is like the principle of Star Trek's replicators and their transporters, Earl Grey, hot! But this annihilation is a big clue as to where antimatter went. We know this annihilation happens because of particle accelerators. When high-energy particles are smashed together or they naturally go through beta decay, tiny bits of antimatter are just created. Scientists clearly want to study this, but they need to hold on to those atoms of antimatter. And therein lies the rub. Our universe is full of matter. Whenever scientists create a particle of antimatter, it hits the mattery walls of the container and will instantly annihilate itself. How frustrating would that be? There's literally no way to hold antimatter in place, or there wasn't until now. In 2002, the Alpha collaboration team at CERN announced that they'd trapped 38 antihydrogen atoms for 172 milliseconds each. There was a breakthrough at the time, but that's not a lot of stuff, or for a very long time. Then, in 2010, scientists trapped hundreds of antimatter atoms for more than 15 minutes, giving them time to explore how these mysterious things work. With this study, published in Nature Physics, as a base, cosmologists believe the Big Bang somehow created more matter than it did antimatter. Not a lot more, mind you, but more. A piece in The Guardian describes it as an infinitesimally small excess. Then, in the seconds after the Big Bang, all the matter and antimatter annihilated each other in huge amounts of energy, leaving behind just matter. Of course, that's a hypothesis, but so far the lack of asymmetry, or the fact that matter and antimatter seem to behave exactly the same and not different, is super confusing for scientists. If there was asymmetry, then they could predict why the matter survived this great annihilation. But so far, they don't know. One study is currently using supercomputers to try and find out the tiny differences between matter and antimatter, so maybe we'll see soon. Otherwise, though, antimatter is dead useful. Star Trek, obviously in fiction, famously uses it to power spacecraft, but this might actually make sense and work out of fiction. Closer to home, though, antimatter could be combined with traditional nuclear technologies, which could kick off fusion reactors. Positron emission tomography involves putting these antimatter positrons into the human body, knowing that they will annihilate and emit that predictable 511 keV of gamma rays, revealing tumors and mapping the patient. 1.1 million people went through PET scans in 2005 alone. And with a little more energy in the right place, those antimatter annihilations could even be used to hyperlocally treat cancer without harming surrounding tissues. Look guys, matter matters. But it's not just about matter versus antimatter. There's also states of matter: solid, liquid, gas, plasma, and there might be a new one too. Julia looks into a possible new state of matter here.
The researchers created a new type of material that could change the way we make electronics. This metal does all kinds of things. It acts like an insulator, superconductor, metal, and magnet, but its superconducting properties are the most interesting.
After all this research, I am so pro-antimatter, but what do you think? Does it even matter? Let us know in the comments. Subscribe so you get more D News. We'll see you next time.